All right, everybody, welcome back for another deep dive. Today, we're going to be looking at the Pythagorean Theorem.
Ooh, fun.
And this is one of those things that, a lot of people have heard of it. A lot of people maybe even remember it from school. But we're going to kind of go a little bit deeper with it today and really try to understand how it's useful. Like, how is this an important thing?
Yeah.
Why should anybody even care about it?
Exactly. So it's, more than just this formula you memorized back in the day.
Right.
A plus B, the CC. What does that actually mean?
Yeah, what does that even mean?
How do we use it?
Yeah, and we've got 4 word problems that we're going to kind of work through today. And each one, I think, will give us a slightly different perspective on how to use this thing.
Fantastic.
So are you ready to get started?
Absolutely. Let's do it. Let's start with a classic, okay? We've got a ladder leaning against a wall.
Okay. A very common.
Very, very common.
Example.
So imagine you have a 10-foot ladder.
Okay.
And you've leaned it against the wall. And the base of that ladder is 4 feet away from the wall.
Okay, so the bottom of the ladder is 4 feet away.
Exactly, from the wall.
All got it.
So how high up on the wall does that ladder actually reach?
So it's like, like it makes a triangle, right?
Yes, it's a right triangle in disguise. So the ladder itself is the hypotenuse, that longest side of the triangle.
Right.
The wall is one of the legs.
Okay.
And then the ground is the other leg of the triangle, exactly.
Okay, I'm seeing it.
And so we can plug these values into the Pythagorean theorem, which, as you may recall, is A plus B, BB, ACC.
Okay. And
we can use that to figure out the length of that missing side.
All right, so just plugging in the numbers, we get that. The height on the wall is about 9.165 feet.
That's right, about 9.165 feet.
And it's not a nice whole number.
Exactly.
And that you might expect from, like, a textbook problem or something.
Yeah, it's not a perfect integer, right?
Yeah, but it shows us how the real world doesn't always fit into those neat categories.
It doesn't, right. And that's why we need tools like the Pythagorean theorem to kind of navigate these situations.
Yeah.
Okay, so let's move on to another scenario, right?
Okay.
Something you might encounter on a soccer field.
Okay.
Imagine a soccer field that is, let's say, 100 meters wide.
Okay.
And 130 meters long.
Okay, so a pretty big field.
Yeah, decent size. How could we figure out the distance across the field diagonally?
So you mean like if you were standing in one corner?
Yes, and you wanted to run?
And I wanted to run to the opposite corner.
Exactly.
Because that distance.
Okay, yeah, that makes sense. And once again, we've got a hidden right triangle here.
Okay.
The width and the length of the field are our legs.
Right.
And that diagonal line is our hypotenuse.
Okay, so it's the same setup?
It's the same setup, different context.
Right. Okay.
Exactly. And so using the Pythagorean theorem, we can find out that that diagonal distance is approximately 164.01 meters.
Wow, that's a long run.
That is a long run.
Yeah.
But it has practical applications, right?
Oh, absolutely.
I mean, coaches might use this.
Yeah, for sure.
To plan drills. Groundskeepers might use this.
Yeah, that's a good point.
To calculate the shortest path across the field.
Right, because if you're driving a lawnmower or something.
Absolutely.
You don't want to go all the way around.
You want to take the shortcut.
Right.
Exactly.
Okay, so it seems like the real key here is to recognize these right triangles.
Recognizing the right triangle. That's kind of step one.
Okay, so let's try another one.
Right, let's do it.
How about a rectangle?
Okay, love it.
Let's say we have a rectangle that is 10 centimeters by 15 centimeters.
All right, 10 centimeters by 15 centimeters. Got it.
And we want to find the diagonal.
Yeah.
So if I draw a line from one corner to the other.
Exactly, yeah.
How long is that line?
Well, if you cut that rectangle in half with that diagonal, what do you get?
You get 2 triangles.
2 right triangles.
Right.
So once again, we can use the Pythagorean theorem to figure out the length of that diagonal.
And what do we get?
We get approximately 18.027 centimeters.
Okay.
For that diagonal.
So I'm seeing a pattern here.
What's the pattern?
Every time we're Ogan. We're finding a right triangle.
Yes.
And then we're using that equation to find a missing piece.
That's it. You got it. Finding that right triangle using the equation to find a missing piece.
To unlock something we didn't know.
Exactly.
Okay.
So let's take this idea out into nature, all right?
Okay.
Let's imagine a hiker starts at their base camp and they walk 10 kilometers due west.
Okay.
Then They climb a 12-kilometer mountain.
Okay.
Straight up.
So they've made like two sides of a triangle. Right?
They've made those two legs of a right triangle.
Right, exactly. So what if they need to get back to base camp quickly?
Okay, interesting.
Like what's the shortest distance?
Distance, right.
Back to base camp.
As the crow flies.
Right.
Yeah.
So that would be the hypotenuse.
That's right. That straight line back to base camp.
Okay.
That's your hypotenuse.
So we can use the same equation again.
Pythagorean theorem comes to the rescue once again.
Right. And we get the distance is about 15.62 kilometers.
That's it.
Okay.
About 15.62 kilometers.
So I think what these problems are really showing is that the Pythagorean theorem isn't just some abstract, formula.
Exactly. It's not just some equation in a textbook, right?
Right.
It has real-world applications.
Right.
It helps us understand distances and relationships all around us. And what's even more amazing is that this theorem, which was discovered, over 2,500 years ago, it's still foundational to fields like architecture, engineering, even GPS technology.
Wow, that's incredible.
Right. So it's really, really cool how something so old is still so relevant today.
So I guess the takeaway here is that the next time you see a triangle,
yes,
especially a right triangle.
Especially a right triangle.
Think about the Pythagorean theorem.
Right. It might be lurking.
Yeah, it might be there.
In the background, helping us understand the world around us.
Well, that's all the time we have for today.
All right.
But thanks for joining us.
Always a pleasure.
And we'll see you next time.
See you next time.